Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Ahmed Usayd Muhammad Yousuf Ali. My metric number is 1926573. So this is the project presentation for system analysis and design. The topic that was assigned was chess club record system. So the objective of this course project is to create a mock project to convert a chess club's physical record into a digital workspace. We have to create project cost estimations, project schedule, use cases, activity diagrams, sequence diagrams, and mockups, and more. This is a table showing the total cost of the project and its breakdown. So starting at the top, the first two rows in the IT personnel cost section is the cost of the project manager and one system analyst. So the project manager will cost around 20,000 ringgit a month for 3 months, totaling up to 60,000 ringgit. The system analyst will cost 15,000 ringgit a month for 3 months as well. So both of these will add up to a total of 105,000 ringgit with the IT personnel cost. Next, moving on to the hardware and software cost, we start off by the server instance, which will be used to host the backend and the website. The instance itself will cost about 100,000 ringgit. The database will be used to hold the records and other relational data. This will cost around 20,000 ringgit. Next is desktop and a laptop for each of the developer. So assuming it costs 6,000 ringgit per unit, it will total up to 12,000 ringgit. So the various licenses will total up to around 10,000 ringgit, and this gives a subtotal of 142,000 ringgit for the subtotal of hardware and software costs. Moving on to the other costs, training will need to be carried out on the IT personnel of the company so that they will know how to use the system once we hand over the system to them. So assuming we train 4 people, it will cost around 8,000 ringgit, which breaks down to 2,000 ringgit per person. So that totals up to a grand total of 255,000 ringgit. Next up is the project schedule. So the project schedule is where the entire process of developing the system is broken down and explained. So we'll start off by sitting with the stakeholders and gathering information and requirements to build a system. This stage is called requirements gathering, and it will span for about 2 weeks. By the start of the second week of requirements gathering, we can begin analysis on the system specification. This will also take around 2 weeks. And upon completing the analysis, we can begin designing the system. So the system will begin designing the system on the 4th week. So the back end of the system will be developed over the span of 3 weeks, and the front end will take about 2 weeks. Once the system is completely designed, once the system design is complete, the documentation of the system can begin, and this will take a maximum of 2 weeks. Following that, we can begin the testing of the system, and by the second week of the testing on the system, the issues that will be found will be resolved and corrected. And once we're done with the fixing, we can finally push the system into a live server. This is the implementation stage, and after pushing it to the live server, we can start getting feedback from the users, and we can also start implementing on the feedback. So if there's any issues, we can start fixing those issues, and if there's any suggestions, then we can implement those suggestions. This is a use case subsystem. So there are 4 subsystems. There is a user subsystem, an operation subsystem, reporting subsystem, and the feedback subsystem. So this shows a few use cases that will be used in the system. So we'll start with the new chess club member. They can register into the system, and this can only be completed upon paying the club entrance fees. Hence, this is why it includes the include tag. So upon successfully registering, the IT admin will also be notified. Next up is the existing club member, which has the most use cases. Starting on the operation subsystem, an existing member can view all the members in the club. They can also view the past matches, and they can also schedule a new match. So scheduling a new match will require the user to add match details. In the user subsystem, an existing member can edit their profile. They can submit an application for renewal. Their application for renewal will only be successful after they complete payment for the renewal fees. They can also view their past matches on the user subsystem. In the feedback subsystem, they can give suggestions to the club so that the club can improve. The time actor will trigger a weekly event of generating weekly reports, which includes getting all the match details from the past week. The customer service can implement the suggestions that they got from the user. Next up is going to be a detailed use case scenario of creating a new match. So this is authored by me, and the intent of this use case is an existing chess club member schedules and sets up a new chess match. So the primary actor in this is existing chess club member, and the secondary actor is the system. Now, the precondition and the assumption of this use case is that the user is already a club member and logged into the system. Success post condition will be that a new chess match is created, and the fail post condition is that there will be no change. The step-by-step of this scenario starts off with the user logging into the system with his or her credentials, and then the user selects the schedule new match option on the navigation bar. A form will be given to the user to fill out with the required fields. The form, as you can see over here, will contain the match participants, they will contain the time, they will contain the date of the match, they will contain the venue of the match, and invites and guests of the match. So the user will fill up the form with the correct details and they will submit it to the system. The system will receive the form's information and they will check the information to see if there is any conflicting details, such as if the opponent is available for the match or if the date and time is available for the match as well. So if all the checks are passed, the system will auto-approve the event and the invites and the notifications are sent out to the guest and the opponent. If there is any error, the user will be notified and they will have to change the error in order to actually successfully create a new match. The user will be redirected to a successful page if the information given is correct, and the user will have created a new match. So this is an activity diagram of the same use case. So the diagram starts off with the user logging into the system. The user will then select the schedule new match option and the user will fill out the new form. So once the user fills it out with the correct information, they will submit. The system will receive the form submission and they will check if there are any conflicts in the system. If there are any conflicts that they find, that the system finds, they will be redirected to the form with the error messages and they will have to rectify. But if there are no conflicts and there are no conflicting details in the system will approve the request and start sending out the invites to the invitees or the guests, and the opponent will get a notification about the match. Then the new match will be created and the use case ends. Next up is the sequence diagram of a detailed use case. So it will start off by the user creating a new match in the browser, and the browser will redirect the user to the form. The form will have to be filled up by the user. Once the user completes the form and submits it, the browser will send the form to the system where it will be checked for any conflict. So if there are no conflicts, the event will be created and the notification will be sent out to the invitees and the opponent. But if there are any conflicts that the system finds, they will be redirected to the form again with the error message, and the user will have to correct the incorrect information and submit it again. After which they will have to be revalidated by the system. After that, the user will be redirected to a successful page and the use case ends over there. This is the class diagram for the use cases that were mentioned earlier. There are 4 classes: user, operations, feedback, and reporting. Each of these classes have their own functions. So for the user classes, there is the edit profile, renew membership, view previous matches, and register. For the operation class, there is the view member method, view matches method, schedule matches method. Going to the feedback class, there is 2 methods here: submit feedback and implement suggestions. In the reporting class, there is also 2 methods: generate report and get past matches. There is a person abstract class that contains the attributes name, phone number, email, date joined, and age. All of these attributes have a type of string except for age, which has a type of integer. Each of these attributes have a get method to return the name and phone number and etc. There is 2 subclasses from this person superclass. The club members have their own member ID and chess level. These are both integers. There are also 2 methods to return the ID and the level as well. The IT administrator subclass has 2 attributes of clearance code and clearance level. They are both integer values, and they also have a get method for each of the attributes. So the next part of the presentation is to showcase the prototype built for a specific use case. The specific use case is creating a new chess match using the website interface. So as you can see here, this is the home page where the user will land upon going to the chess club website, and all the way on the top right over here you can see there's an option that says create new match. But before a user is able to select this, we are making the assumption that the user is logged in with a valid account. Once a user is logged in and authenticated, the user can select create new match, and then he will be directed to a form page. So as you can see here, the first two fields are asking for the user's ID and the user's name. The ID is the unique ID that the user was given when he signed up for an account on the chess site. The second two fields are the opponent's ID and the opponent's name. Afterwards, the user will have to input the date and the time of the match. The user will also have to select type of match, whether will it be in a physical location or if it will be an online match. If the user decides to select physical location, they will have to choose a venue from the given option, and then they can proceed on to the next step, which is to add invitations. So this is an optional stage, and the user can enter the member's ID or the member's name separated by a semicolon to invite other members to view and spectate the match that the user and the opponent will have. Upon completing the required fields, the user can submit the form. Once the user submits the form, the server will process the data that it received from the form, and it will check whether the date and time is available and if there is no other clashing matches. And another thing that the backend will check is whether or not the opponent is available for a match on that date and time, or if the opponent is in general available for the match. If these validations are passed, then the user will be directed to a successful page where it will say match created, followed by a smaller message saying thank you, the opponent has been notified and the invites have been sent out. In an actual working system, in the backend, they will send a notification to the opponent and the invites will be sent out to the invited people on the list that the user inputted. Beneath that, there is a button that will allow the user to return home. Now, at any point during the backend validation of the date and time and the opponent's availability, if there is any errors, then the user will be redirected back to the form page with errors as a flash message. So as you can see over here, there are two errors that a user can receive, and for this prototype and for the sake of simplicity, I have put both the errors at the same place, but in an actual working system, the user will not receive both errors at the same time. So the first of the two errors that the user may receive is that the date and time that they have selected is not available to organize a match. Then the user is instructed to select a different date and time. The second error that the user may receive is that the opponent that they have chosen will not be available to organize a match. Then they will be instructed to choose a different opponent to have a match with. So these are the errors that the users may receive. That is the entire presentation of the prototype. And that is all. Thank you very much for listening to my presentation. Assalamu alaikum wa rahmatullahi wa barakatuh.